There is a gap in our observations and understanding of a critical time in the universe. We have measurements of the cosmos from a time when it was only 400,000 years old. And we have observations of the earliest galaxies, an epoch when the universe was only 480 million years old. And we have nothing in between. This era, from 400,000 to 480 million years, marks an extremely important time in cosmic history. The earliest stars began to ignite from primordial hydrogen. These stars then collected into the very first galaxies. And those galaxies formed the earliest galactic clusters, the first sculptor of the cosmic web. We have virtually no observations of any of this happening. Astronomers call it the Dark Ages. Our window into this period is currently being built, the James Webb Space Telescope. Designed as the successor to the Hubble Space Telescope, it will look primarily in the infrared, a wavelength rich in information about the universe when the earliest stars and galaxies were forming. It will be the largest telescope to ever fly in space. It is so large that it must be carefully folded to fit into the rocket that will launch it, and then unfolded when deployed. It has a primary mirror over 7 times that of the Hubble Space Telescope, and will house 4 main science instruments and a total of 18 detectors: the mid-infrared instrument, the near-infrared camera, the near-infrared spectrometer, and the fine guidance sensor tunable filter camera. Current plans are for the James Webb Space Telescope to observe continually for 5 years, with a goal of extending that mission lifetime to 10 years. It will reside far from the Earth, its rocket placing it in what is known as the L2 point, over 1.5 million kilometers away, well outside the orbit of the Moon, allowing it to forever keep the radiation from the Sun, Earth, and the Moon behind its protective shield. This location, far from its home, will protect sensitive instruments from these bodies and help keep them cool. Once there, however, we will not be able to travel to it again, its lifetime limited by onboard propellant, the fuel that makes orbital corrections to the spacecraft. The James Webb Space Telescope is among the most sophisticated instruments ever built, using technology that had to be invented specifically for its mission. Everything must deploy and work flawlessly the first time. It is too far away to fix, and there is no space shuttle to take us there. Because it sees primarily in the infrared, this telescope must be kept as cold as possible. 6 giant deflectors will unfurl, providing protection from the sun's radiation. Behind and underneath, a momentum flap corrects for the torque on the spacecraft created by the solar wind. An enormous 6.5-meter segmented primary mirror will unfold into place and focus the heavens on a secondary mirror held aloft by unfolding supports. This mirror will be large enough to resolve the distant blobs seen by Hubble into detailed galaxies. Once deployed, the James Webb Space Telescope will join a pantheon of instruments that have done more to progress our knowledge of our place in the universe than in any other time in history. The discoveries and knowledge gained about the universe from this telescope promise to be unprecedented. They will elevate it as the only worthy successor to the greatest scientific instrument ever built, the Hubble Space Telescope.